Hey guys, guess what? This is it. We've made it. We are going to take our last set of notes. We are going to do just a really quick mini section on what's called transformations, but that's it. We made it to the end of our year. So let's go ahead and let's do this. All right, guys, we are going to start this last really quick and really brief section. What we're going to take a look at is what's called transformations. And this is what you need to know about transformations. So we'll take an image and what we'll do is we're going to transform it. We might slide it to a new location, we might flip it, we might rotate it, and those changes to that original shape again is what's called a transformation. And so in our last week together, guys, we're going to take a look at 3 different transformations. I'll go ahead and write them down. Translation is actually the most common. What you'll see here, it's a slide. So your figure is actually going to stay the same shape. What's going to happen though, is it's going to move to a different location. Reflection is a flip. You can think of it as a mirror image. Think about when you look in a mirror and you see your own reflection. So it's going to be the flip of an object. And it's going to be reflected over a specific line. So we'll take a look at that. Another common transformation is a rotation. A rotation is just like it says, it's when your object moves around a specific point. We're not going to get into too much detail with this, but it is one of our main transformations. Dilation is also a transformation, so again, your shape is going to be altered in some way. The difference with this one though is that with the dilation, the size changes. So in these 3, the size does not change, just the position changes. Whereas a dilation, it's going to either get smaller and shrink in size or it's going to get bigger and grow. So right now what you're looking at are, again, these examples of transformations. So again, rotation, what's happening is that we start with an original image here, and then it's getting rotated or turned around a specific point. With a reflection, again, what's happening is that we have an image here and it's getting flipped. So you'll notice that it's that flipped or mirror image of that triangle. And then here with the translation, we'll start with some sort of image and it's getting shifted. So in this case, this is moving upwards. And so again, these are just examples of transformation. And so you'll notice that none of the shapes change here in size, just the location of them is changing. And so how that's a little bit different though is that here is an example of a dilation. So here it says resizing, but again, that's what a dilation is. So we're starting with an original image. In this case, it's a triangle, and you'll notice that the new image though gets larger. And again, it's dilated to become larger or bigger. All right, so here's our first example. We're going to take a look at a translation. Now, a translation is just a slide. So what's going to happen is that this triangle that's right here is going to slide, or it's going to shift into a new position. So what you'll notice here is this is the pre-image. So that's the original image that you're starting off with, and that's this triangle here. The points listed here are the ordered pairs that make up that triangle. All right, so how you're going to know how to shift your shape is there's going to be a rule written. It's going to look something like this. So you're going to see that it's going to start with X, Y, and so they're telling you to take the ordered pair, and they're going to tell you to shift it or slide it somehow. So for example, our rule might look like this. X plus 4, and then Y minus 6. And so what that means is we're going to take our X and Y values here, these ordered pairs, and we're going to apply this rule to it. So if you notice, what's happening is they're saying that for every X value, we're going to add 4. So we'll go ahead and do that together. And so when you do this, you're going to get what's called the image. And that's going to be the new shape after we translate it. We're going to go ahead and we're going to apply our rule to our first point. So for example, when we take a look at this, A, the first thing it tells us to do though is that to every X value, it says that we're going to add 4 to it. So for example, here if it's 0, we're going to add 4 to 0, which is going to become 4. Or same thing with B. Notice here with B, X is -4, so we're going to apply the rule of adding 4. -4 plus 4 is going to become 0. And then same thing with C. -4 here is X. We're going to add 4 to it, which is also going to become 0. All right, and so we're also going to do that for our y's though. So notice the rules for the y's is to subtract 6 though. So in this case, I have y is 4, and I'm going to subtract 6 from it. So 4 minus 6 is going to be -2. B, same thing. I'm going to plug in 1. 1 minus 6 is going to be -5. And then same thing with the last point here. Y is 6. 6 minus 6 is going to become 0. What you're going to notice about this image though is that these points are going to be indicated with this little apostrophe. And that apostrophe is just going to indicate that these are our new points or represents the change from the original. So let's go ahead and graph these. So A now is at 4, -2. All right, and so again, what you'll notice is that our triangle then went from this red one, and it's translated or it's slided kind of diagonally down this way to now this blue image here. So again, with your new images, you want to just make sure that you're putting that apostrophe to indicate that this is the new one. All right, sometimes what you'll see people do is that they'll go ahead and shade in this new image here, just to indicate that this is the new one or this is the one that has been produced after it's been translated here. The other thing that I actually want to point out to you guys though is how it's been translated. So if you take a look at this rule here, for the x values, 4 was added. And if I show you this here, notice here this is where A is. A has been shifted over 1, 2, 3, 4. So here, this is just telling us that we have shifted over to the right 4. So again, anything on that x-axis here is going to tell us that we're moving either left or right. How do you think that the y changes the graph? Think about which way y goes. It goes up and down. So hopefully that you notice that by -6, we're actually going to be shifting down 6. So this is right 4 and then down 6. And you'll notice that here too. So look at where A is. If I go down 1, 2, 3, 4, 5, 6, and then over that 1, 2, 3, 4, I'll end up at my new point here. All right, so just like last time, if you take a look at this, remember the x-axis goes left to right like this. So -3 just means that we're going to be moving over to the left. So you might say right away that this is shifting our graph over 3 units to the left. And then think about y's. Again, remember on your y-axis, y go up and down. This is plus, so again, it should mean that we are going up 7. So up 7. So again, without having a graph, that's one way that you guys could figure out what is the slide or what is the movement that's happening here. So for example, let's go ahead and add in a graph to this. Here is an example again. So this time, instead of a triangle, our image or our pre-image is a rectangle. Same thing, we have some ordered pairs here, and what we want to do is apply the rule to it. So what we can do is like we did in the last problem is we can subtract 3 from every x, we can add 7 to every y, or again, if you can read that rule, we know that this is going to shift left 3 and then up 7. So let's actually do it that way this time. So I'm going to go ahead and take A and I'm going to shift it over 3 to the left. So 1, 2, 3. And then it's shifting up 7. 1, 2, 3, 4, 5, 6, 7. So here's the new point for A. So A, and I'm going to put that little apostrophe. So I'm going to do the same thing for B. All right, so just like before, if you want to shade it in, you can. This is going to be your new image. And so in the case that it asks for the points, you could quickly read from your graph that A is here at the point -1, 4. You might say that B is here at the point 4, 4. So without having to do that math each time, you can go ahead and just shift it over that way as well. So again, that's called your translation, and that's when our image slides to a new location. All right, so this is what's called a reflection, and a reflection is essentially just a flip. So it's the mirror image of something, like looking at your reflection in a mirror. Same idea here. You're going to start with a shape. In this case, we have a triangle, and again, that's referred to as our pre-image. So it is the starting point before we change it or transform it. With a reflection, you'll get specific directions as to where we're flipping the shape. All right, so what we're going to do is we're going to take this shape here and we're going to flip it over the y-axis. And how we're going to do that is we are going to make sure that it is equal distance away from whatever line we're flipping it over. So for example, if you take a look at B right here, B is 1, 2, 3, 4 spaces away from that y-axis. So when we graph the new one, we're going to make sure that it is 1, 2, 3, 4 spaces away. So B, and I'm going to go ahead and put that little apostrophe to indicate that. So with our new image, we're going to say that B is here at the point 4, -3. All right, you'll do the same thing with C here. C, we can see that it's 1, 2, 3, 4, 5, 6 points away from that y-axis, or again, what we're flipping or reflecting it over. So we're going to make sure that when we do it again, it's going to be 1, 2, 3, 4, 5, 6 places away again. So C, and again, apostrophe here. So C, the new image here is going to be at the point 6, -8. And then we'll do the same thing like we did with A. So A in this case is 1, 2, 3, 4, 5, 6, 7, 8 places away. So when we flip it over here, we're going to make sure that it is also 8 places away. So A here again is going to be at the point 8, -3. And then again, if you were to connect those here, here is our new image. And again, you'll notice it's the same shape, except it's just flipped over that line. And that's what's happening with our reflection. So let's go ahead and take a look at one more example. Here is our next example then for reflections. So again, reflection is going to give you a specific line to reflect the shape over. In this case, it says x is equal to 3. Now, as a quick reminder to you guys, what that means is this. Anytime you have x equals, what you want to remember that this is going to be a vertical line going up and down. Versus, let's say if you had a y equals would be a horizontal line. And so I'll show you that before we finish this problem. But here, x equals 3 means that there's going to be a vertical line at 3. So on your x-axis here, you're going to find 3. And that's right here. We're going to go ahead and put in our vertical. All right, and so this is what we're going to be flipping over. So we want to make sure that our rectangle is equal distance away from this line here. So just like we did before, you're going to just count out the spaces to make sure that it's equal distance. So for example, if I start with A, you'll notice it's 1, 2, 3. So my new one's going to also be 1, 2, 3 spaces away. All right, and so this would be my new shape then. So again, you'll notice that it is both equal distance away from our line that we reflected it over. All right, now let's go ahead and kind of change up this equation though. I'm going to erase what I wrote here. And let's say that I said we want to reflect this line instead over the equation y equals -2. All right, so hopefully you remember what I said. Anytime you have y equals, you're going to have a horizontal line. So on your y-axis here, you're going to find -2, which is right here. And we're going to just draw in our line here, horizontal line like this. So instead of flipping over left to right this way, this image is going to be flipped downwards now. So it's going to shift downwards. So same idea. You're just going to count how many spaces away from the line it is. In this case, it is 1, 2. So your new one's going to be 1, 2 right here. All right. So again, you'll notice same shape, but again, this time it has been flipped over downwards. All right, and so what I'll remind you is this, is anytime you have an x equals equation, that's going to be an equation that goes up and down, versus if you have a y equals equation, that's going to be from left to right. So watch for that. All right, guys, this is our last transformation that we're going to look at, and it's called dilation. So kind of think about when you go to the doctors and they dilate your pupils enlarge. And so that's what this transformation is. Your image is either going to expand or it's going to shrink based on what's called a scale factor. The instructions that you'll see with dilation are this. Dilate the image by a scale factor of, let's say, 2. And so what that means is that for all of these numbers here, you are going to take these and you're going to multiply all of them by 2. And that's how we're going to get our new image. So let's go ahead and we'll do that math together. We're going to multiply everything by 2. 2 here times 2, so that's going to be 4. And you're also going to do it to your y. 4 times 2 is going to be 8. Okay, we're going to do that for b also. All right, and so we'll go ahead and we'll plot those 3 points. All right, and so what you'll notice about this is we still have this right triangle here, just like the blue one, except that it has been enlarged. So it's been dilated by a scale factor of 2, so it's grown. Let's go ahead and take a look at one final example then, when we dilate by a fraction. All right, guys, so this will be our final example. We're going to go ahead and dilate this image, so this large rectangle, by a scale factor of 1/4. All right, so then what that means here is we're going to take our points and we're going to multiply everything by that 1/4 here. So remember, everything is being multiplied by 1/4. And so what happens is both the x and the y, though. All right, and so again, what you'll notice is that we still have this rectangle shape here. The difference here is this time, though, it has shrunk, and that's because our scale factor is 1/4, so it's only 1/4 of the size. All right, so those are our 3 different transformations that we will be working with. That should be enough to get you through the homework, so go ahead and try that, and then hopefully that made sense. Guys, we did it. That's it. I wish we were together to celebrate this, but I thank you guys for following along. I hope you guys are doing well and taking care of yourselves. Please know that I enjoyed our time together during our school year, even though it was cut a little bit short. But have a wonderful summer. Please come visit me if you guys have time next year. And then I guess for one final time, bye guys.